Assalamu alaikum. This is third lecture of our chemistry series. Today we will study isotopes. First of all, I will explain three similarities and two differences by which you can identify an isotope. Three differences are: both the atoms have same number of protons. Both the atoms have same number of electrons. Both have same atomic number. Two differences are: both have different number of neutrons. Both differ in total number of protons and neutrons. This means they have different mass numbers. As in the previous lecture, I have studies society, technology, and science paragraph. In this lecture, I will do same. So let's have a quick look on this. Dalton's atomic theory explained data from many experiments to show it was widely accepted dis- discovery of subatomic particles and isotopes proved that some of the Dalton's ideas about atoms were not correct. Scientists did not discard his theory, instead, they revised the theory to take into account new discoveries. This shows how prevailing theories bring about changes in them. So, quick look. So we have a quick look on the definition of isotopes. Isotopes are atom of an element whose nuclei have the same atomic number but different mass number. This is because atoms of an element can differ in the number of neutrons. Isotopes of hydrogen. First of all, I will uh, I will teach you three types of isotopes: protium, deuterium, and tritium. And now we will study isotopes of hydrogen. Hydrogen has three isotopes. Hydrogen 1, protium, has no neutron. Almost all the hydrogen is hydrogen 1. Its symbol is, this is its symbol. Hydrogen 2, deuterium, has one neutron, and hydrogen 3, tritium, has two neutron. The symbols of these are here respectively because hydrogen 1, also known as a protium, has only one proton. Adding a neutron double its mass. So this is differences between ordinary water and heavy water. Ordinary water boiling point, melting point is 0, boiling point is 100 Celsius, and density at 25 Celsius is 0.9 and 701 gcm cube. Heavy water melting point is 3.81 Celsius, boiling point is 101.2 Celsius, density at 25 Celsius is 1.044 gcm cube. Isotopes of hydrogen. Isotopes of carbon. Carbon has three isotopes: carbon 12, carbon 13, and carbon 14. Almost all the carbon is carbon 12. Its symbol is C. This is its symbol. It has 6 neutrons and 6 protons. Carbon 13 has symbol of C, 13 by 6. It has 7 neutron and 6 proton. Hydrogen 14 has 8 neutron and 6 proton. Different forms of carbon are black or grayish black solids except diamond. They are odorless and tasteless. They have high melting point and boiling points and are insoluble in water. So these are the its accuracy, or how much percentage this is in original form. So 98.8% are hydrogen. Uh, what hydrogen is this? Let's have a look. This is hydrogen. Wait. This is hydrogen protium, and 1.1% is no 98.8% is carbon protium, 1.1% is carbon deuterium, and 0.009% is carbon tritium. Isotopes of chlorine. There are two natural isotopes of chlorine: chlorine 35 and chlorine 37. An atom of chlorine 35 has 17 proton and 18 neutron. An atom of chlorine 37 has 17 proton and 20 neutron. Chlorine 35 occurs in nature about 75% and chlorine 37 about 25%. Chlorine is grayish yellow gas with sharp, pungent, irritating smell. It is un- fairly soluble in water. So what's the next? Next is uranium. You can pause the video and read that because I already explained you two or three isotopes. Now we will study uses of isotopes. Number one, radioactive iodine. 131 is used as tracer in diagnosing thyroid problem. Na24 is used to trace flow of blood and detect possible constrictions or obstructions in the circulatory system. Iodine 123 is used to image the brain. Cobalt 60 is commonly used to irradiate cancer cells in the hope of killing or shrinking the tumor. Carbon 14 is used to trace the path of carbon in photosynthesis. Radioactive isotopes are used to determine the molecular structure. Example, sulfur 35 has been used in the structure determination of thiosulfate SO20 oxygen 3 minus 2 ion. Radioactive isotopes are used to study the mechanism of chemical reactions. Radioactive isotopes are used to date rocks, soils, archaeological objects, and mummies. So this is for today. I will don't take this lecture so long. The next topic, electronic configuration, we will cover in the next lecture. I am trying to keep lecture shorter than the 10 minutes, so you have a great interest, because when I do a long lecture, you don't watch full. So that's why I am doing short lectures. So this is for today. Inshallah, we will meet in the new lecture. Allah Hafiz.